So hello everyone. In this video, I'm going to explain the transportation problem in operation research and how to solve it using Microsoft Excel. This is a very useful optimization technique to minimize the cost of transporting goods from multiple sources to multiple destinations. So let's dive in. First of all, we need to know what is exactly the transportation problems referred to. The transportation problem is a type of linear programming problem. The goal is to determine the most efficient way to distribute a product from several suppliers, also called as sources, to several consumers, also called as destinations, while meeting the supply and the demand constraints and also minimizing the total cost. So, now, why it is really important to apply the transportation problem. So, this method is widely used in logistic and supply chain management, whether it's distributing raw materials, finished goods, or even optimizing staff allocations. Transportation model help to save money and resources efficiently. So now we'll be using the sample problem in the Excel sheet, which is right over there. So here's a sample problem. We have three sources, which are S1, S2, and S3, and three destinations, which are D1, D2, and D3. The number in the table are cost per unit of transportation. The row-wise total are supply values, which are also referred here as capacity, and the column-wise totals are the demand values. Now, I will copy this cost per unit table. I will paste it over here and will mention it as volume table, and will also delete this costs. So over here, we will be looking for our final data or the solution we are looking for. So for now, I'll cut my capacity and move it to here. And also same goes for the demand. Now this can be referred as warehouse requirements, and this will be warehouse demand. And also over here it will be factory supply. So I'll be adjusting it a bit. And this one will be factory capacity, which is already written. I'll just add factory over here. My mistake. So now factory supply will be basically is equal to sum of these three, which is basically right now 0, and I'll do same for each and every one. And over here for the warehouse demand, I'll be selecting all these three to get the sum. So initially now as nothing has been set over here, that's why we are getting 000 everywhere. Now I require an additional cell to be initialized. This cell will tell us what is the total transportation cost which will be initiated by this whole process. And this will be referred as the sum product of the cost per unit, comma, the volume, which is initially 0 right now because of this. So now we will be opening the data, then we'll be going to the solver. As we can see, its solver parameters. We have to set the objective, which will be the transportation cost. Then we have to set its whether we have to do its maximum or minimum or value of. Over here, we are focusing on the primary constant, which is primary result, which is minimum. So how we can do it minimum? By the changing the variable cells. So over here we'll be selecting these cells, and now as we know there are three sources and three destinations which will be adding up, and the sum will be 6. So we will have 6 constraints over here. So first we have the factory supply, which will be less than the factory capacity. And now similarly we'll do for this and this and this as well, and also this and this. Now we have added 3 constraints in the solver. Now we'll be focusing on the demand constraint. So we have to focus that the demands which are being asked should always meet. So now we will be adding the other constraints, which will be warehouse demand. And over here, to meet the demand, we have to set the bar to equal, and also constraint will be requirements. It's added. And now again, we will be doing the same. So now I guess we have added our 6 constraints. So now it's over here. It is GRG nonlinear, simplex linear programming, and evolutionary. So we will be focusing on our simplex linear programming. So I'll be clicking on it, and now we'll be solving it. And yes, we got the answer. So I'll click OK. So now here we got the optimal solution, which means from S1 to D3 we will be sending 30, from S2 to D2 we will be sending 50, from S3 to D1 we will be sending 20, and the warehouse demands are met as the warehouse requirements as well as the factory supply, which are met according to the factory capacities. And here the optimal cost is 330. Thank you for watching.